Alright, good morning. So I'm on page 23. I'm outside right now. It might be a little bit noisy with some road traffic every once in a while, but I'll get through this as quick as I can. We're going to do something called the chain rule today. So it's going to be the derivative kind of in two parts. We're going to be doing like an outer derivative times an inner derivative. So what this means is, if you have a function like this, usually I would say, okay, let's write this twice. So this would be like x squared minus x plus 1, and then another one. So we have to write it out twice. But then, let's say multiply it out, and we're going to FOIL it out, and then we're going to do the derivative. But there's an easier way, a quicker way to do it than doing the expansion first and then doing the derivative. We also get into more problems where we have complicated things like this, where we have a 1/2 here. We don't know how to take a half of this as an exponent. So that's where the chain rule comes in. So the chain rule looks like this. So you start with some function. The derivative of that, now it looks kind of weird because you have this u involved and then you have a derivative of u. Remember, anytime you see the slash, that means the derivative. So what's going on in this problem is that they are going back to this, so looking at this. So they made the inner part, the x squared plus 2x, and then they did the derivative. And then they made like an outer part where they did all this to the 1/2. So they have like an outer part, an outer function, and an inner function. Okay, so you can do this all with u's and take them out and stuff, but you don't actually have to. So what you're doing is actually saying, okay, if my function is this, what you're going to do is do the derivative of the outer function, so outer derivative, and then multiply it. So this is the chain part where you're connecting it to the inner derivative. So it's all going to be kind of connected in like a one sentence, like going from left to right. So what I'm saying about the outer derivative is saying, okay, we're going to leave this all as like the inner part right here. And the outer part is just going to be anything that's on the outside of the parentheses. So what you do first is treat this like the derivative. We usually do the shortcut method. So take the exponent times the coefficient in front of the parentheses. So it's 5, whatever the parentheses are. And I don't care what's in there because I'm just doing the outer part, and do the exponent down by 1. Okay, so when we do this, we just leave the parentheses alone. So we're doing the outer part, so do that part first. And then multiply or attach it to the derivative of the inside. So we did the outside part, now we're doing the inner part. So 6x minus 4, and that's your whole thing. Alright, so the next one says e to the 2x squared minus 8x plus 5. Now this doesn't have parentheses like that or an exponent like before. So what you do is you treat it like the first function you see. You do e. So e is like the outer, and this is like the inner. So you treat it, leave it alone. Do the outer function. Remember, the derivative of e was e, and whatever's there stays there. So you do the outer one, and then we multiply and do the inner derivative, 4x minus 8. And that's your whole thing. Okay, so when you look at the notation, this is the outer derivative times the inner derivative. They add in another variable just to say I have a function inside of another function. Okay. I don't know what's going on with this packet. I apologize. Let's go to... I'm going to go to on page 26. Just to go to this. So I'm going to bring all of this up top We've talked about this. And all of this is to the -1 power. Don't distribute in, leave it like that. So do the outer function. Do the derivative first. Take the -1 times the coefficient in front, -1. Leave the inside alone, because I'm just dealing with the outside right now. Times the derivative of the inside, so 27x squared minus 8x plus 1. Okay, that's all we're going to do right now. So I would like you to finish up, try your hand at, there's other problems like this, numbers 1, 2, and 3, and on number 2, treat this as 2x minus x squared all to the 1/2. Then do the derivative, same thing here. And then going backwards, I suppose. You have 5, 6, 7, 8, 9, and 10. So try your hand at these. On number 7, treat this like sine x to the 6th power. Okay, so that's where you have the outer and the inner. Sorry about all the traffic. Talk to you later. Bye.